Boiling point increases as the number of carbons increase. So the higher the surface area, the higher is the boiling point. Branching decreases the surface area, so the lower the boiling point is going to be. As for melting point is affected also by the surface area. So the more compact the molecule is, the more symmetrical the molecule is, the higher is the melting point. So melting point here is opposite of that of the boiling point with alkanes. Okay. Bicyclic compounds are compounds that are made up of two cycles. The cycles can be either different or the same. Now, how these two cycles are connected with each other determines the type of the bicyclic compound. So, if you have the two cycles that are connected by 2 points, then in this case, we're going to have these two examples. The 2 points can be two carbons in there. And I have here an example of two cycles. I have two cycles. Each cycle is made up of 6 carbons here. So this is going to be the first cycle. And this is going to be the second cycle. And those two cycles are connected by 2 points. Now notice that these two cycles are fused with each other. So this type here, we're going to call it fused bicyclic system. And whenever we want to name this cycle, we're going to go ahead and number it first from the joint points. So you're going to start numbering either from this carbon or from this carbon, depending on the substituents. But let's say for this one, we have no substituents in here. We're going to start numbering it from this carbon. And then you're going to move along the side of the cycle that has more carbons. In this case, I have 4 carbons on this side. So on this side, I have 4 carbons. And on the other side, I have 4 carbons. This is not including the joint points. So you're going to move along the side that has more carbons. This side has more carbons and this side has more carbons, so it really doesn't matter. So we're going to go ahead and move along this side here. It's going to be 1, 2, 3, 4, and 5. Now, once you're done from the number of carbons in the first cycle, you have to hit the second joint point before you jump into number the second cycle. So this is going to be 6, and that is going to be 7, 8, 9, and 10. So to name this now, we're going to put the name bicyclo, and we're going to open the brackets, not parentheses, brackets. Now the brackets are going to include the number of carbons in both cycles. So in this cycle in here, excluding of course the joint carbons. So in this cycle in here, I have 4 carbons. You arrange the number of carbons from the more to the less. So I have 4 carbons in here. Now the second cycle has 4 carbons. And then in between, I have 0 number of carbons. There's no bridge coming out. So this is going to be a 0. You cannot skip the 0 because the moment I look and see a 0 in here, I know that the type of bicyclic system is a fused bicyclic system. And then you count the total number of carbons, including the joint carbons in there. So this is a total of 10 carbons. So you put the word decene in there. Let's have another example of a fused bicyclic system. A cycle of 6-membered rings, and then a cycle of 5-membered rings in there. So as we said, label the joint points first. and then start numbering. Since I have no substituents on either one of these cycles, I can start numbering from either this carbon or this carbon. So I'm going to start numbering from this carbon here. You're going to move along the cycle side that has more carbons first. So this one has more carbons, so you have to move along this side. This is going to be 2, 3, 4, and 5 in there. And it has more carbons because this side has 4 carbons. Let's highlight the carbons on this side. It has 4 carbons, excluding the joint points. And this side here has 3 carbons. So this is why you start numbering from the side that has more carbons in there. Once you hit 5, you need to finish up and go over 6 in there. So this is 6. And then go over the side of the cycle that has less number of carbons. This is 6, this is 7, and that is 8, and that is 9. So I have a total of 9 carbons in there. And you start your naming with bicyclo. You open the brackets. You arrange the numbers from the more to the less. So I have 4 carbons on this side. I have 3 carbons on the other side. And I have 0 carbons in between 1 and 6. And then the total number of carbons in my bicyclic system is 9. So this is going to be none. Let's have another example with a substituent on the cycle. So if I have a cycle of 6-membered rings and then a cycle of 4 membered rings in there, these are my 2 cycles. So this is going to be my first cycle here, and this is going to be my second cycle in there. This is a fused bicyclic system. So the first thing that you do is you locate the joint points. Let's say, for example, I have a CH3 over here. Okay, so I'm going to start numbering through the joint points. Now my priority here is to move and give the lowest number of carbons to the side with more carbons than less carbons. Now notice that the substituent on the side with less carbons, I'm just going to ignore this. But once I reach this carbon in numbering, if I can give this carbon the lowest number, I'm going to go ahead and do that. So we're going to have on this side here, so this is my 4 carbons on this side. Let's go ahead and highlight those carbons. I have a carbon, 2, 3, and 4. So on this side, I have 4 carbons. And on the other side, I do have carbon and 2. I have 2 carbons in there. This is on the other side. So here I have 2 carbons. So definitely this side here has more carbons. So I'm going to start numbering towards this side. I'm starting with my joint carbons. So this is going to be carbon number 1, moving carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. And then once I reach carbon 6, I have the choice of going all the way here and making this carbon number 7. And this is going to be carbon number 8. Let's see if we can number it in another way so that we can give the substituent the lowest number. So let's say, for example, if we start numbering from this carbon as carbon number 1. Again, I have to move along the side with more carbons. So this is going to be 2, it's going to be 3, that's going to be 4, it's going to be 5, and this is going to be 6, this is going to be 7, and now this is going to be 8. So no, this is better. So now when I name that, I'm going to start by naming my substituent first. And here I have on carbon number 7 a methyl. It's exactly like you name the alkane. So you have 7-methyl, and then you start with naming your bicyclo compound. So this is going to be a bicyclo. Open the brackets in there. And then I have on one side, I have 4 carbons. On the other side, I do have two carbons, and in the middle, I have zero carbons between the joint points. And the total number of carbons here is going to be 8, which is octane. The other type of bicyclic compounds that are still connected by 2 points, we call this bridged bicyclic system. And with the bridged bicyclic system, please refer to the conformation of cycloalkane lecture just to elaborate more on how to draw a cyclohexane. So if we have a cyclohexane, we know that the carbons of the cyclohexane are sp3 hybridization. So this is not a planar structure. So drawing a cyclohexane having carbons all lie in the same plane is not right. In reality, cyclohexane exists as a chair conformation and as a puckered conformation, meaning some of the carbons they lie outside the plane just to relieve the angle strain and the energy strain of the structure. So a similar representation of cyclohexane is this over here. So whenever we want to represent bridged bicyclic system, we're going to represent a cycle of 6 carbons. So this is going to be the same as this structure there. We could have represented those two as a puckered conformation. So if we want to do this, then we're going to draw the bicyclo 4,4 decane. So this guy over here, we can draw it as this. Okay, these are the 2 points of connection in there, and you still have 4 carbons on this side, and you still have 4 carbons on the other side, like we did over here. So this is exactly the same as this structure. So back to our bridged bicyclic system. So for the bridged bicyclic system, let's have an example in there. You need to have 2 cycles. And these 2 cycles, they need to be connected by still 2 points, and there should be a bridge in between them. So let's highlight the 2 cycles there. This is going to be the first cycle. And this is going to be our second cycle. And the 2 carbon connection is this carbon here and this carbon there. So see the difference between the fused bicyclic system and the bridged bicyclic system. Both are 2 cycles. This is why it's a bicycle. The fused, the point of connections have no carbon in between. Here, the point of connections have 1 carbon in between. Of course, it can be more than 1 carbon, but this is an example of 1 carbon in between. So to name a bridged bicyclic system, the first thing that you would need to do is start numbering again from the point of connection and move along the side that has more carbons. So here I have 2 carbons on this side. So on this side here, I do have 2 carbons. And on this side here, I do have 2 carbons. So honestly, it doesn't matter. And on this side here, I have 1 carbon. So definitely I'm going to move either to the right or to the left, meaning to the sides of the 2 carbons rather than the 1 carbon. I'm going to choose this side over here and go by 1 and 2. So going by 1, this is going to be 2, this is going to be 3. As we did for the fused bicyclic system, we are going to number the connection. So you start from the connection and you end up in the connection in there. So this side has 2 carbons. You number from the more carbons to the less carbons. So we're going to number the 1 carbon at the end. So you start by numbering this side over here. We're going to move to the other 2 carbon side. This is 5, this is 6 in there. And then the last one is the 1 carbon that is going to be a 7. So now when I want to name it, It's going to be a bicyclo, open the brackets. So it's going to be 2 carbons on this side, 2 carbons on the other. And then in between, I don't have a 0 anymore because 0 is for the fused. In between, I have 1 carbon. So this is going to be 1. And then the total number of carbons, including the joint points, which is 7. So this is going to be a heptane. Let's have another example in there. So if I have this, and then I have 3 carbons in between. So this is going to be 1, this is going to be 2, and this is going to be 3. Again, we're going to label the joint carbons, and then we're going to start numbering from the joint carbons. Since I don't have any substituent, I don't care. I can start numbering from this carbon or from this carbon. So here I'm going to start numbering from the carbon on the top. And now I need to move along the side that has more carbons. So here I have 3 carbons, here I have 2 carbons, and here I have 2 carbons. So you're going to go ahead and move along the side that has 3 carbons. So it's going to be 1, 2, 3. This is going to be 4. And then I need to hit the joint. This is going to be 5. I have to hit the joint in there. Now, once I hit the joint carbon, then I have the option of going either ways because I have similar number of carbons. But if this side had more carbons, I need to go this way. But I'm going to go this way anyways over here. So this is going to be 6. This is going to be 7. And then it's really up to you over here because there are no substituents to give them the lowest number. So we can go 8, we can go 9, or we can go 8 here, we can go 9 there. In either cases, the ending is going to be nonane. This is going to be a bicyclo. Open the brackets. It's going to be 3 on one end. It's going to be 2. It's going to be 2. And then the total numbers is going to be 8. Number is going to be 8, 9 carbons actually. So it's going to be a nonane. Okay. Now let's say, for example, if I had this, if I had a cycle of, okay, so if I had something like that here, and if I had a CH3 over there, okay, I want to go ahead and name that. Now this is a bridged bicyclic system. Why? Because I do have 2 points of connection in there and I have a bridge coming out. Now in all of these sides in there, the bridge is going to be 1 carbon. It's 1 carbon here, 1 carbon here, and 1 carbon there. So in this case, I'm going to go ahead and start and give my substituent the lowest number. So it's going to be 1. I'm going to go this way because I have a substituent. It's going to be 2. That is going to be 3. And then I have the option. Let's go ahead and have a CH3 over here. Then in this case, you're going to have 4 in here, and then you're going to have a 5 in there. This is a cycle of, or a bicyclic of 5 carbons. So your ending is going to be a pentane. So start numbering and give it a 2,4 dimethyl. And then bicyclo. Open the brackets in there. And then you have the 1, 1, and another 1. And it's going to be pentane. We have more examples in the notes for the fused. Here I'm using the puckered conformation to represent those cycles. Again, please refer to the conformation lecture in this chapter in order to understand more how to draw the puckered conformations. We have here, it's a bicyclo. It is 2 carbons on the side. So here I do have 2 carbons. So this is why I have a 2. I have 2 carbons on the other side here. This is why I have a 2. and in between these two I have zero number of carbons. This is why I have a zero in there. Start numbering. This is going to be 1, 2, 3. This is 4, this is 5, and this is 6. So this is why my total number of carbons is hexane. This is another example of a bridged bicyclic system. So you start on this side, I have 2 carbons. On this side here, I have 1 carbon, and here I have 1 carbon. So definitely I'm going to start by numbering towards my 2 carbon side in there. And I'm going to give this um, ethyl group my lowest number. So this is why I didn't start numbering from this to be carbon number 1, because if I did this, then the ethyl is going to be on carbon number 3. And I want it to be the lowest number in this case. If you can give your substituent the lowest number, please go ahead and do that. This is going to be 2,5-diethyl. It's going to be bicyclo, and then it's going to be 2,1,1, and then hexane. Now, let's say if you are given the name and you want to go ahead and draw your bicyclic system. So here I have bicyclo, 4, 3, 3, and this is a dodecane. Dodecane means it's a 12 carbons. So the first thing that you need to do is do the 2 points of connection. I know that this is a bridged bicyclic system because of the 3, right? And I know it's a bicyclic, so I need to have 2 points of connection. So draw your 2 points of connection. On one side, I have 4 carbons. So go ahead and do the 4 carbons in there, or connect them at the end. And then on the other side, I have 3 carbons. So this is going to be 1, this is going to be 2, and this is going to be 3. Let's go ahead and connect them so that we can draw the 3-carbon bridge. So here you go. Okay. And then now in between those two, I need the 3 carbons as well. So I need a carbon, I need a carbon, and I need a carbon. So these are my 3 carbons in there. So see, what did I start with? I started with drawing the points of connection, and then drawing the carbons. I started with the more carbon side. So these are my 4 carbons in there. And then I did my 3 carbons on the other side. So this is going to be my 3 carbons. And then I did the bridge in there, which is the 3 carbons. Connect everything together. And then this is going to be your bicyclic system. Now, the second type of bicyclic system is 2 cycles connected by 1 point. So instead of having 2 points in there, our cycles are connected by 1 point. So these are connected by 1 point. In this case, the bicyclic compound, we're going to name it spiral. So if I have something like this, and if I have, okay, now you can easily see that I have 2 cycles in there. So this is going to be a bicyclic system, but I need to differentiate it from the fused and the bridged bicyclic system. So this is connected, these 2 cycles are connected only by 1 point. They are not connected by 2 points in there. So this is an example of a spiral bicyclic system. So to name that, we're going to start with the word spiral and open the brackets in this case. And then to differentiate from the naming of the bicyclic system, the naming of the bicyclic system, we started our numbering from the highest to the lowest, right? So here we're going to start from the low carbon cycle to the higher carbon cycle in there. And we cannot start numbering from the joint. So we don't start numbering from this point of connection. We always start numbering from the side of the cycle that has the lower number of carbons, So this side here has 2 carbons, and this side here has 1, 2, 3, and 4 carbons. So start with the 2 carbon side and start numbering from that side in here. So my carbon 1 will be now on this carbon. Of course, if I had substituents here, I'm going to start numbering this carbon to be carbon number 1. So start numbering from here and go move along the side of the cycle just to hit the joint, and then move along the higher number carbon cycle. So that is going to be 2, that is going to be 3, and then 4, 5, 6, 7, and 8. It really doesn't matter here if you go 3, 4 or if you go 3, 4. It doesn't matter. So the name is going to be Spyro. Since I have 1 carbon connection there between those two, I don't have a bridge coming out. It's not fused. I don't need to put a 0 or anything like that. I start my carbons in the cycle by numbering the less carbon cycle in there. I have 2 carbons on this side. And then the more carbon cycle, I have 4 carbons on the other side. And that's it. These are 2 numbers. So Spyro has 2 numbers for each of its cycles. And then I count the total number of carbons. It's 8. So this is going to be octane. Let's say if I have another example. So here you go. I have a cycle of 4. And then I have a cycle of 6. So I have a cycle of 4 and I have a cycle of 6 in there. And then I do have a CH3 coming off here. So now we're going to go ahead and start numbering from the cycle that has the lowest number of carbons. And again, don't number from the joint. So I'm going to go ahead and number from this carbon over here. We're going to check 2 ways. So it's either we're going to start numbering from this carbon here or this carbon there, just to see if we can get the lower number for the substituent. So if I number from here, then I'm just going to go ahead and move along. So you number from this carbon and you move along so that you can cover the entire cycle. And that is going to be carbon 2, carbon 3, and there. So this side has 3 carbons, and now this is 4. You have to hit the joint carbon in here. You cannot go 3 and 4. So once you start from the cycle, you have to finish numbering all its carbons in there. 4. Now I have 2 choices. I can go this way and do 5, or this way and do 5. If I go this way, then the CH3 will get the lowest number. So this is going to be 5, this is going to be 6, 7, 8, and 9. So my name in this case is going to be a Spyro. I do have 3 carbons on the side, so this is going to be 3. And I do have 1, 2, 3, 4, and 5 carbons on the other side, so that is going to be 5. And then, of course, I forgot my substituent in there. So before Spyro here, please put 6-methyl. It's a dash. And then you have the name Spyro 3,5. Okay. And then the total number of carbons is 9, so it's going to be none. Okay. There are other examples for naming bicyclic compounds in the extra problem set that is posted. Please practice this. There are also more examples on these in the class notes. Also practice those problems as well.